excess pressure inside a liquid drop. Now, let us assume this is a liquid drop. From outside, it is PO, and from inside, pressure is PI. PI is greater than PO. So if this happens, what happens? Due to the excess pressure, the drop will increase in size. Let this radius be R, and this radius is R plus delta R. Due to the excess pressure inside, the molecule increases in size. Now we have to find an expression for this excess pressure, Pi minus P naught. Now what we are going to do, we are going to find out the work done in two different ways and equate the two work done. Now, from the first principle, work done can be written as force on a small area into displacement and then you sum up all the work done. Now what is force? Force is the excess pressure Pi minus P naught. Let me write this as P. So force is pressure into summation of all the areas into displacement is delta R. Now this is pressure. P is actually the pressure difference. If you add up all the areas of this surface, it is a sphere. So it is 4 pi r square into delta R. P is actually the excess pressure. Now from the second principle, work done can be written as surface tension into surface area created. This is surface tension is T. And what is the surface area created? My final surface area is 4 pi r plus delta r whole square. And my initial surface area was 4 pi r square. This is T, 4 pi r square plus 4 pi delta r square plus 8 pi r delta r minus 4 pi r square. Now these two terms cancels. As a square of a very small quantity, delta r is very small and a square of very small quantity is negligible, so this becomes 0. So this work done becomes T into 8 pi r delta r. Now both are work done. So what you are going to do, we are going to equate the two work done. From the first principle, this is my work done. And from the second principle, this is my work done. So what can we say? P is the excess pressure into 4 pi r square delta r is equal to surface tension into 8 pi r delta r. Now delta r cancels, pi cancels, 1 r cancels, 4 2s are 8. So excess pressure becomes, here you have 1 r twice T by r. So excess pressure becomes twice T by r. Now here only one surface increased. Now it might be a case like we might have three different cases of drops. Say it might be a liquid drop. If it is a liquid drop, then what happens? Inside you have liquid, full liquid. Then there is only one free surface. Which is expanding. So in this case, excess pressure is twice T by R. Now you might have a soap bubble. In a soap bubble, actually, it is made up of soap. So this is soap. So here you have two free surfaces. Here is one surface and inside is another surface. So here you have two free surfaces. So when the bubble increases in size, inside surface also increases, outside surface also increases. So surface area created will be into 2. So here you will have into 2. There will be 2 surfaces growing. In this case, excess pressure will be 4T by R. It will be multiplied by 2 because 2 surfaces will increase. So here surface area created will be into 2. So here it will be into 2. So excess pressure will be 4T by R. Now you might also have an air bubble. Now in air bubble what happens? Outside is liquid and inside is air. So how many free surface you have? You have only one free surface. So here excess pressure is twice T by R. Now to demonstrate this, let us take an experiment. Let us take two tubes A and B of the same apertures. They are connected by a tube E. Two tubes A and B. They are connected by a tube E. Now, this tube is immersed in a soap solution. Now, as soon as it is immersed in a soap solution, you have two spheres one small and one big. They are immersed in a soap solution and you have two bubbles, bubble X and bubble Y. Now this one has radius R1, this one has radius R2. Now if you open this connection, what will happen? Here excess pressure P1 is twice, for the soap bubble it is 4 T by R1 and here the excess pressure is 4T by R2. Now R1 is less than R2, therefore P1 is greater than P2. So as soon as this tube is opened, what happened? Here there is excess pressure. Here there is less pressure. So what happens? Air starts flowing from excess pressure to low pressure. So this will decrease in size and this will increase in size. This will, although it was small, it will further decrease and this will further increase. Till what? Till both the pressures become same. And when will the pressures be same? These two pressures, surface tension is same. P1 will only be equal to P2. P1 will be equal to P2 when R1 becomes equal to R2. That is, the curvatures will be the same. That means this curvature, this is the drop, this is the slope. The curvature of this and the curvature of this will be the same. Because here there was excess pressure, here there was less pressure. Air will flow from here to here until the pressures are same, and this can only happen when R1 becomes equal to R2. So, equilibrium will come about, will be reached when the surfaces of both the bubbles have the same curvature. But mind you, curvature does not mean that they should be of the same size. Not the same size. Their curvature should be same. Their curvature should be same, but size is not same. This will further decrease, this will further increase. Now, if this concept is extended to the excess pressure or the pressure difference across a curved surface, if this is extended to across a curved surface, say you may have a liquid like this surface, or a surface like this, or a surface like this. So this is my liquid over here. This is my liquid over here. And this is my liquid over here. Here you see the atmospheric pressure is P0 because it is open to the atmosphere. Now just beneath, as this has gone inside, this is more. Here pressure will be less. So what will be the pressure here? It will be P0 minus 2T by R. Just now we have done the excess pressure is 2T by R. Here the pressure is more. Here the pressure is less. Here both the sides pressure is same. Here this side has moved inside, so this pressure will be more. Outside is atmosphere, so inside pressure will be P0 plus 2T by R. So when you have a curved surface, you can calculate the pressure on both the surfaces since excess pressure is 2T by R.